So when I think of green, the first thing that comes to my mind, I think of lush environments. I think health. I think opportunity. I think luck. I picture perfectly manicured lawns. I also picture lush forests and everglades. But I grew up in the West. And when I think about the iconic images of the West and I think about the colors that define our environment, it's not green. It's shades of brown, shades of orange, golds, I heard that, as well as yellows. I don't see a lot of green in there. It makes me wonder, as a Westerner, why do I associate green with a healthy environment? Well, I'm going to blame those folks back east. Around the mid-19th century, manifest destiny took hold and westward expansion occurred. We had Easterners move out in droves, and they brought with them an expectation that there were going to be a lot of natural resources, specifically a lot of water resources, and that those water resources would be able to sustain the development of ranching, agriculture, as well as mining industries. They really believed that as Americans, it was their God-given right to expand across the continent and to really make sure that the U.S. empire went from sea to shining sea. There wasn't enough water. So in 1907, the U.S. Bureau of Reclamation was established. And they were there specifically to manage water in the West and make sure that there was enough water to support a growing economy and burgeoning populations. In the mid-1930s, specifically 1935, Hoover Dam was built. It was completed and they started damming the Colorado River. This dam was the largest project, the first large project that Reclamation started up. And to this day, Hoover Dam on Lake Mead is the largest reservoir on the Colorado River. It holds roughly 2 years of flows of the Colorado River in its Pacific reservoir. The tradition of really managing water in the West in order to support the economy continues today. This map shows different watersheds across the United States. In green, this is where local supplies are actually adequate in order to meet local demands. But where you see shades of red, yellow, and orange, that is where the demands are outstripping local and naturally occurring supplies. You'll see most of the shades of red are in the Southwest. That is not to say that we are running out of water in our specific region, but rather that we rely on pumping, reservoirs, and large-scale conveyance systems to make sure that we have enough water to meet our demands. And therein lies really the stunning thing about water in this particular region. It requires a massive amount of electricity to make sure that we all have enough water in the West. Pumping, moving, conveying water requires a lot of energy. Let's put this in perspective. If you live in New York City, you use roughly 27 kilowatt hours of electricity to move and pump 10,000 gallons of water. 10,000 gallons of water, that's what a household of 4 will use on average in a month. If you live in Northern California, you're using about 40 kilowatt hours. Yes, for your 10,000 gallons. So yes, you're using more water. That's because you're pumping more water from groundwater. But if you're living in Southern California, where I grew up, you're using 127 kilowatt hours for every 10,000 gallons, the same amount. You're using 5 times as much energy just to get water to your household than you would be if you were in New York City. Of course, we're here in Phoenix. So let's talk about Phoenix. Let's talk about Arizona and what the energy or the cost of the water, the energy cost of the water resources here actually is. For Phoenix, again, this is just pumping and moving the water, about 48 kilowatt hours per 10,000 gallons. Now, if you live in Arizona, about 40% of your water comes from surface water supplies, specifically from the Colorado River. The other 40% comes from groundwater. Let's start talking first about the energy-water nexus as it applies to your groundwater resources. So right now, this theater is actually above an aquifer. That aquifer, to get to the top of that water, it's about 300 feet down. 300 feet below where I'm standing right now, there is water. To pump that water up requires about 30 kilowatt hours for 10,000 gallons. You can say, Kristen, 30 kilowatt hours, that's actually not that much electricity. But given how much water we actually use and how much is extracted from our groundwater, that actually adds up. And the further you draw down that aquifer, the more energy it takes. In California right now, the drought, we just heard about the drought that has taken hold in the Central Valley. In the last 3 years of drought, the cost to agriculture, the revenue loss, has been $1.5 billion. Of that, $500 million, 1/3 of that total, can be directly attributed to the increased cost of energy because they need more energy to pump more water out of their groundwater. Bottom line, this adds up, and it adds up quickly. So now let's talk about your surface water supplies. Your surface water, 40%, again, the other 40%, if you will, of your water supply comes from the Colorado River. But the Colorado River, it's kind of far from here where you guys are in Phoenix. And the way that the water is moved from the Colorado River is through the Central Arizona Project. And when you think about Central Arizona Project, or CAP, you need to think about the number 3. Number 1, it cost over $3 billion to construct. Number 2, it travels over 330 miles from the Colorado River via Lake Havasu to Phoenix and then on to Tucson. Number 3, it actually moves up over 3,000 feet in elevation between Lake Havasu and Tucson. Moving water that high requires a tremendous amount of electricity. And the last thing, it requires every year, CAP uses over 3 million megawatt hours of electricity. It's the number 1 user of electricity in the state of Arizona. So think about where you're getting your water if you live here. Of course, where does the electricity come from? That's a tremendous amount of energy that we need. 90% of the electricity for CAP comes from the Navajo Generating Station, which is arguably one of the most polluting coal-fired power plants in the United States. Last year, this power plant emitted over 19 million tons of carbon dioxide. 40% of the electricity generated here, in other words, 40% of the carbon, that carbon is what you guys are all using to basically make sure that you get water here in Phoenix and also in Tucson. So if you really want to consider what your greenhouse gas footprint is and what your carbon footprint is, start looking at how much water you're using, because that can go a long way to saving your carbon footprint and minimizing greenhouse gas emissions. But that message, that nexus between energy and water and the role of climate, that is not just a message that's important here in Arizona. There's over 3,000 miles of pipelines, aqueducts, and canals across the southwestern United States. If you live in the West, you should be asking yourself the question, where does my water come from, and how is my water resource being powered? There are a lot of opportunities there, both in terms of investment in renewables, but also in looking at where our power plants and really the mixture of electricity in our portfolio. But make no mistake, our climate is changing. We are looking at impacts into our water resources and the potential for diminished water resources in the future. Water managers, believe it or not, they know this. They're planning for this. And one way that they're doing so is by considering additional infrastructure. These are the pipelines that we can expect to come online in the next probably 30 years across the southwestern United States. The challenge is that several of these actually have energy requirements that are greater than that of the Central Arizona Project. So I actually am hopeful about this. I think one of the things about water resources in the West and the connections that they have with energy as well as with food and agriculture, the amazing thing there is that everybody here in the West can find something that they believe in or something that is important to them across all of those different sectors and all of those different topics and issues. I'm also optimistic because efficiency and conservation of our water resources can take us a long way. But it is going to take a really a paradigm shift in making sure that as a society, we all prioritize saving water. I think that it's also really going to require that we change the way that we think. We need to abandon the thought that a green landscape is a healthy environment. We need to re-embrace brown and really re-brown the West. And as this fabulous sign from drought-stricken California says, we really need to make brown the new green. I grew up on the Colorado River, camping, fishing. I spent my summers on Lake Powell, Lake Mead. My husband and I have made the pact that we're going to make sure we paddle and raft every inch of the Colorado River. I just hope that the Colorado River is still going to be there for my children because it's a bloody important resource. And I think that by connecting it to energy and other things that we really care about, we're going to be able to save it. Thank you.